There's a man in Vermont who grows carrots the size of baseball bats. His tomatoes weigh 3 pounds each. His lettuce heads are so dense you need 2 hands to lift them. And he hasn't bought fertilizer in 22 years. Not because he's cheap, not because he's lucky, but because he discovered something that most gardeners spend their entire lives ignoring. Something happening right now beneath your feet, in the dark, where billions of organisms are working 24 hours a day to build the most powerful growing medium on Earth. And if you learn to feed them instead of fighting them, your garden will transform in ways that seem impossible until you see it with your own eyes. This is about living soil, and once you understand how it actually works, you'll never look at dirt the same way again. Most people think soil is just ground up rock mixed with dead plants. Something inert, something you add chemicals to when you want things to grow. But that's not soil, that's dust. Real soil is alive, crawling with bacteria, fungi, protozoa, nematodes, and arthropods that form networks so complex scientists are still trying to map them. These organisms don't just live in the soil. They are the soil, breaking down organic matter into nutrients plants can absorb, creating soil structure that holds water and air, protecting roots from disease. And when you kill them with synthetic fertilizers and pesticides, you're not just harming microscopic creatures. You're destroying the entire engine that makes plants thrive. Here's what nobody tells you. Chemical fertilizers are like fast food for plants, quick energy, no substance. And the more you use them, the more dependent your garden becomes because those chemicals bypass the soil's natural systems and deliver nutrients directly to plant roots. Which sounds efficient until you realize what's actually happening. The soil organisms that would normally be feeding your plants start dying off because they are no longer needed. The soil structure collapses because there's no organic matter being processed. Water retention plummets, disease resistance disappears. And within a few seasons, you have dead dirt that can't grow anything without constant chemical inputs. You've created an addiction, and the only way out is to rebuild what you destroyed. But here's the part that changes everything. Living soil doesn't just grow bigger vegetables, it grows them faster, with less water, with fewer pests, and with flavors so intense they taste like a completely different species compared to store-bought produce. Because when plants get their nutrients from a living soil ecosystem instead of chemical salts, they develop complex sugar profiles, higher mineral content, and defense compounds that make them both tastier and more nutritious. This isn't theory, this is biochemistry, and you can prove it in your own backyard. The foundation of living soil is organic matter, not just any organic matter, but a constant supply of carbon-rich and nitrogen-rich materials that feed the soil food web and create the conditions for explosive microbial activity. Think of it like this. Your soil is a city, and the organisms living there are the workers. If you don't feed the workers, the city shuts down. But if you give them what they need, they'll build infrastructure that lasts for generations. The fastest way to feed your soil is with compost. Not the bag stuff from the garden center that has been sitting in plastic for months and smells like sulfur, but real compost, made from kitchen scraps, garden waste, fallen leaves, grass clippings, and if you're lucky, animal manure. Piled together in a heap where bacteria and fungi break it down into dark, crumbly humus that smells like a forest floor after rain. Here's how to build a compost pile that actually works. Start with a base layer of coarse material like small branches or straw to allow air circulation from the bottom. Then alternate layers of brown material and green material. Browns are carbon-rich, dry leaves, straw, shredded paper, cardboard. Greens are nitrogen-rich, fresh grass clippings, vegetable scraps, coffee grounds, manure. The ratio matters. Aim for roughly 3 parts brown to 1 part green by volume. Too much green and your pile turns into a slimy, anaerobic mess that smells like death. Too much brown and decomposition slows to a crawl. Add water as you build. The pile should be as moist as a wrung-out sponge, not dripping, not dry. Just damp enough that microorganisms can move and multiply. Then leave it alone for a week. Let the bacteria colonize, let the temperature rise. A well-built compost pile will heat up to 130, 140, even 150 degrees Fahrenheit in the center as thermophilic bacteria devour the organic matter and release energy as heat. This heat is important because it kills weed seeds and pathogens that might otherwise survive and cause problems in your garden. After a week, turn the pile, pull material from the outside to the center. Pull material from the center to the outside. This introduces oxygen, which the aerobic bacteria need to keep working efficiently. Without oxygen, the wrong bacteria take over, and your pile starts producing methane and hydrogen sulfide instead of finished compost. Turn your pile every 2 weeks. Keep it moist, and within 3 to 6 months, depending on temperature and materials, you'll have finished compost, dark, crumbly, sweet-smelling, ready to spread over your garden beds. But here's where most people stop. They make compost once or twice a year, spread it on their beds, and think they're done. They're not, because living soil isn't something you create and maintain. It's something you feed continuously. The organisms in your soil are eating organic matter constantly, breaking it down, cycling nutrients, building structure. And if you stop feeding them, they die, which means you need a system for adding organic matter to your soil year-round. Not just in spring, not just when you remember, but as a regular practice that becomes as automatic as watering. One of the most powerful methods is mulching. A thick layer of organic material spread over the soil surface that slowly breaks down and feeds the organisms below while suppressing weeds, conserving moisture, and moderating soil temperature. The best mulches are carbon-rich materials that decompose slowly. Straw, not hay. Hay has seeds that will sprout and turn your garden into a weed farm. Shredded leaves. Wood chips, though these should be used carefully around annual vegetables because they tie up nitrogen as they decompose. Grass clippings, but only in thin layers because thick layers mat down and become anaerobic. Spread mulch 3 to 6 inches deep around your plants. Leave a small gap around stems to prevent rot. And as the mulch breaks down over the season, add more. You're creating a continuous buffet for soil organisms. And every time you add mulch, you're depositing carbon into the soil bank that will pay dividends for years. But mulch alone isn't enough, because while it feeds the fungi and bacteria that break down carbon, it doesn't provide the nitrogen that plants need for vigorous growth. That's where green manures come in, also called cover crops. These are plants you grow specifically to chop down and incorporate into the soil while they still green and full of nutrients. Legumes like clover, vetch, and field peas are the best green manures because they form symbiotic relationships with rhizobia bacteria that pull nitrogen from the air and convert it into a form plants can use. When you chop down a cover crop of clover and let it decompose on the soil surface, you're adding both nitrogen and carbon, feeding both the bacteria and the fungi, balancing the soil food web, and setting up your next crop for explosive growth. Here's a strategy that compounds over time. Plant a cover crop in any bed that's not actively producing food. In fall, after you harvest your tomatoes, sow a mix of winter rye and crimson clover. The rye will grow roots that break up compacted soil and scavenge nutrients that would otherwise leach away over winter. The clover will fix nitrogen. In spring, chop everything down before it goes to seed. Let it sit on the surface as mulch for 2 to 3 weeks, then plant directly into it. You've just added 40 to 60 pounds of organic matter per 100 square feet without bringing in a single bag of compost. And that organic matter will feed your soil organisms all season long. Now here's the part that separates living soil from conventional gardening: diversity. In nature, you never see monocultures. You see forests with dozens of plant species growing together, prairies with hundreds, each plant occupying a different niche. Different root depths, different nutrient needs, different relationships with soil organisms. And this diversity creates resilience because when one plant is struggling, others thrive and support the system. Your garden should work the same way, not rows of single crops planted in isolation. but polycultures where multiple species grow together and support each other. Companion planting isn't just folklore, it's ecology. Tomatoes grow better with basil because basil attracts beneficial insects that prey on tomato pests. Beans grow better with corn because corn provides a trellis and beans fix nitrogen that corn needs. Carrots grow better with onions because onions repel carrot flies. These relationships work because they mimic natural systems where diversity creates stability. But the real magic happens underground. Different plants host different communities of soil organisms. Brassicas like cabbage and kale favor bacteria. Tomatoes and peppers favor fungi. Legumes host nitrogen-fixing rhizobia. Alliums like onions and garlic produce compounds that suppress harmful nematodes. When you grow these plants together, you're cultivating a more diverse and resilient soil food web. More species, more interactions, more stability. And that diversity protects your garden from the boom and bust cycles that plague monocultures. Here's something most gardeners never consider. The soil food web has predators. Protozoa eat bacteria, nematodes eat fungi. Arthropods eat nematodes, and every time a predator consumes prey, it releases nutrients in a form plants can immediately absorb. This is called the microbial loop, and it's the primary way nutrients move from soil organisms to plant roots in natural systems. Chemical fertilizers bypass this loop entirely, delivering nutrients directly to plants, which sounds efficient until you realize you're restarving the predators that would normally be cycling those nutrients and creating a self-sustaining system. Living soil doesn't need external inputs, because the organisms are doing the work. Breaking down organic matter, cycling nutrients, protecting roots. And all you have to do is keep feeding them. There's another layer to this that changes everything: mycorrhizal fungi. These are fungi that form symbiotic relationships with plant roots, extending microscopic threads called hyphae hundreds of feet through the soil, far beyond where roots can reach. These fungal networks access water and nutrients in places roots never could. And in exchange, plants feed the fungi sugars they produce through photosynthesis. It's a trade, water and minerals for carbon. And it's one of the most important relationships in all of agriculture. Mycorrhizal fungi increase a plant's root surface area by 100 to 1,000 times. They make phosphorus available that would otherwise be locked in the soil. They protect roots from disease. They improve soil structure by producing glomalin, a sticky protein that binds soil particles together. And they connect plants to each other, forming underground networks that allow plants to share resources and even communicate. Scientists call it the Wood Wide Web, and it's real. But here's the problem: tilling destroys it. Every time you turn the soil with a rototiller or plow, you're shredding those fungal networks, breaking the connections, forcing plants to start from scratch, and chemical fertilizers suppress it. Because when plants can get nutrients easily from soluble salts, they stop trading with fungi. The relationship breaks down, the fungi die. And you're left with plants that are more vulnerable, less resilient, and completely dependent on you. Living soil requires a different approach: no-till, where you disturb the soil as little as possible and let fungal networks develop and mature over years. Add compost to the surface, plant through mulch. Let roots decompose in place, and over time, the soil builds structure, fertility, and biological activity that makes plants explode with growth. There's a farmer in Pennsylvania who hasn't tilled his fields in 40 years. His soil is so rich and loose he can push his entire arm into it without effort. His vegetable yields are 2 to 3 times the regional average. And he's never used synthetic fertilizer, not once. Because he understands what most farmers have forgotten: the soil is not a medium you extract from. It's a system you invest in, and the returns compound forever.